314, outlet pull boxes, junction box, handhold enclosures. There's a lot of work in 314. Wow. Now, 314 deals with outlet boxes, a light fixture, just making a splice box here, and switches, receptacles, conduit bodies, junction boxes, and handhold enclosures. So it's a pretty broad article. Non-metallic boxes. You only use a non-metallic box with non-metallic raceways and cables. But there's an exception. If you want to use a non-metallic box with a metal raceway, then metal raceways can terminate to a non-metallic box where the internal bonding means provided between all entries. So if I want to put bonding bushings and bonding jumpers, then you can. So non-metallic box, okay, but if you use metal raceways, you're going to have to be bonding all those together. 314.16, number of conductors and boxes and conduit bodies. There's a lot of work here, but we're going to do with this. Boxes containing 6-gauge and smaller conductors must be sized to provide sufficient space for all conductors, devices in the boxes. So you need to make sure when you're smaller circuit conductors that you have enough room in the box. That's kind of questionable, Just one more extension cord. By the way, there is no limit to the number of extension boxes that you can put on a circuit. So you put as many as you want to in there. Here's an example. I mean, how do you put on, there's a switch, there's a dimmer here, and a GFCI receptacle. That is just, wow, that's a problem. You can actually see, I don't know if you can see it there or not. You see where it's pressed in here? Can you see that a little bit? Maybe you can't see that there. You can see where the wires have been pressed in there, trying to push that down to get it inside here. Anytime you see a blue wire out of a box, all right, here, guys, take a look at this. That's never a good sign. I'm just saying. When you see a blue wire knot in a box, I got a feeling all those neutrals are twisted together.
The grays are okay.
Yeah. Okay, so now let's do some box calculations. The first thing is, what's the volume of the box? So you get the volume of the box, and then you add the volume of any extensions you're adding. Here's a plaster ring, or here's an extension ring, or here is a box that has a cover on it that has some volume. So it's a matter of what's the internal volume. That's the first thing you go to. So you get the box volume. And Ryan, what's the volume of a 4-square box? Is there a table 310.16b? Yeah. Is that what
it's A. It's 21 inches.
310.16a says that a 4-square by 1.5 deep box is 21 cubic inches. And then you're going to add an extension box to it, which is going to be 4 squared by 1.5, so that'll be another 21, so that's going to be 42, plus a 7.5, 42, so that's 49.5. That's the volume that we're working from in this application. Now, of course, this is, how much is that 21 square inches? Okay, 1, 2, 3, 4, 5, 6, 7, 8 times 21.
No, that one is a deep, though.
Oh, is there a deep one in there?
Yeah.
Yeah, okay.
Right above.
All right.
Bottom two over here.
Small fittings like cable connectors and raceway fittings, lock nuts and bushings are not counted. See, what we're going to do is this. For us to determine whether this is going to be safe or not, we need to know, well, how much volume do you have? And then we start adding up the stuff that you want to put in it to see if, it's kind of like, okay, I got so many bags or so many, balls that I'm trying to put into a container. Well, how big is the container? And if I know what the volume is, well, then I can start filling it in and I can calculate. Rather than me putting it all in and realize, oop, it didn't fit. So instead of you running all the wires and then trying to make a splice, it didn't work. Best thing is know in advance, what's my volume? What am I going to put in there? Then what are the volumes? Add them all up to see if it's going to work. Let's just do this in advance. So we're going to calculate it. But you don't count wire connectors. You don't count bushings. You don't count fittings that are inside the box. So we forget about that. We know that's part of it. Conductors that come in the box, each one that terminates in the box is going to count as a conductor. Conductors that run through the box that are not going to be used in the box for any reason, in other words, they're not going to be 6 inches in the box, they count as one conductor. So here's one conductor running through. Then that's number 2, number 3, number 4, number 5, number 6. See, we have to count the number of conductors so that we can then use some method to calculate its volume, but you only count conductors that are, first of all, they have to be what, 6 inches in the box and 3 inches outside the box, so we know what the minimum length is going to be there. But a conductor that runs through the box that does not have 12-inch loop means you can't use it. Well, then you don't count that as other than one conductor. Let's look at that graphic again. That's one conductor, 2, 3, 4, 1 second. 1, 2, 3, 4, 5, 6 conductors for the moment right now. Now, if we're going to loop them in, and there's going to be a 12-inch loop, you measure around here. Okay, that's 12 inches. That's 12 inches. That's 12 inches. So now we have 1, 2, 3, 4, 5, 6, 7, as far as conductors are concerned. If you have a dome canopy, then the fixture wires are not counted. That's part of that fan. So we don't worry about that. But it doesn't really matter. You got a dome canopy. You have so much volume up there, it really becomes not an issue at all. Ryan?
If you could go back 2 slides, Mike, because I don't think we're going to cover it. Let's say I decided to pigtail off of that white conductor because I'm going to a receptacle. That doesn't count either.
Oh, wait, do I not have a graphic for that?
No, I was looking for that. So
it's in the textbook.
Right.
And what it says is conductors that enter the box and that terminate the box count as a single conductor. Conductors that run through the box that does not provide 12 inches count as single conductor. Conductors that originate in the box and terminate in the box do not count.
Right.
So therefore, what I should do is maybe have Mike put a pigtail on here, right? And then that pigtail does not count as a conductor because it originates in the box and it terminates in the box. Thank you for that. Let's go now to counting volumes as it has to do with clamps. If you have connectors holding cables, it doesn't count for anything as far as the volume. Yeah, I know what's inside the box, but don't worry about it. Same thing at a raceway. Don't worry about that. But if a box has internal clamps, then the internal clamps are considered to be equivalent to a conductor. So what we're trying to do now is we're kind of adding up conductors, and we're making things to be considered an equivalent to a conductor. So you count the conductors entering the box, terminating, or count as 1. Conductors running through the box that doesn't have 12 inches, they count as 1. It has 12-inch loop in there, it counts as 2 each. The clamps count as 1 conductor volume. And then we'll figure out later on what we're going to do with that. Fixture studs. I don't think we see that very often anymore. That's an old type of system where you'd have like a 1/2-inch knockout and you have this device, and then you have this like horseshoe thing, okay? That's called a hickey. That's old stuff that's done in the 40s and the 50s and sometimes the 60s and 70s. But if you have a stud or a hickey, the stud counts as a conductor, the hickey counts as a conductor. So this really is not relevant to us working in the field because you don't have studs and hickeys. But if you're taking an exam and they said, hey, listen, we have a box. It has a this, a fixture stud. It has a hickey. And you're like, what the heck's a hickey? I mean, at one time in the 70s, a hickey was a function of conduit bending. It's a rigid bending bender. And it was called a hickey. You know, so people got confused with that term there. But back in the 40s, they knew what the fixture hickey was. So go back over here. It's a horseshoe thing that takes from a 1/2-inch threaded entry, and it goes down to a 3/8-inch stub. That's your hickey. That's your stud. Now, each device yoke counts as 2 conductors based on the largest conductor terminating on the device. So this is 1 yoke, 2 yoke, 3 yoke. Each yoke counts as what? 2 conductors. So that's 2, 4, 6 conductors. Plus I got what? I'm going to count conductors only first, right? I have 1, 2, 3, 4, 5, 6. I don't count the pigtails, so I have 6 conductors. Am I right that I have 6 conductors there?
That's what it looks like.
Okay. Plus I have 7, 8, 9, 10, 11, 12 conductors. Over here, I have 1, 2, 3, 4, 5, 6. Oops. 7, 8, 9, 10, 11, 12, 13. So I think we should go ahead and put little numbers around all of these, and then we can count them up. Or at least we should at least identify what? This yoke is 2, this yoke is 2, this yoke is 2. This yoke is 2, 2, 2. And it doesn't matter if it's going to be a GFCI receptacle, a single receptacle, if it's going to be a dimmer, or a single switch. It's still 2 conductors per yoke. A yoke that doesn't fit in a 1-gang box, but you need a 2-gang box, counts as 4 conductors? Well, because it has that kind of volume in there. So that's 4 conductors. Equipment grounding conductors. No matter how many equipment grounding conductors in a box, it counts as 1. Why is that? I don't know. It just counts as 1. But if you add an isolated equipment grounding conductor to the circuit as well, the isolated equipment grounding conductor also counts as 1. So I'm going to count this here. I have 1, 2, 3, 4, 5. I count 7 conductors with this example here on the left.
Great.
1, 2, 3, 4, 5, 6, 7 conductors is what I count in that box.
Yep.
Over here I got 1, 2, 3, 4, 5, 6, 7. I count 9. Here we go. Ready for this? The isolated ground is 1. The neutral in the receptacle is 2. The equipment grounding conductor is 3. The neutral that's feeding through is 4. The hot wire going to receptacle is 5. The blue wire running through is 6. This neutral right here is 7. And 8, 9 is device.
I think so.
So that's how you would do those counting in there. Here's an example. Let's count this one. I have 1, 2, 3, 4, 5, 6, 7, 8. Is that what we have here? Oh, I'm sorry. This is 12 gauge wires. This is existing 12 gauge wire. There's 10 of these.
8, 9, 10.
Existing conductor and device volume is 10 12 gauge wires.
Right.
How many 14 gauge wires can you add to this box? Well, if I have 10 12 gauge wires, you see, we didn't talk about this, but table 314.16b gives us the volume for conductors. And I probably should have a little graphic I probably should add on here, which would be the volume of 12 gauge wire is
2.25.
I don't even show it here.
2.25.
Yeah, I don't show it on here.
No.
It's 2.25. 14 gauge wire is 2. Make sure you take the moment, stop the tape, go in your code book there, and take a look at 314.16b, which gives you the volume of conductors. Because once we count all these conductors up, we got to now get the volume and see how that works out with the volume that we had started with as it relates to the box itself. So take a look at that inside the book in the calculation. Ryan?
You know, and I would challenge you if you're an inspector or a contractor to really learn box fill. It's remarkably simple. Once you've done enough of them, it is so easy. It's insane. But you know, one of the things that I thought was kind of cool over the course of my career with Draper City, when I first started there back in 2002, I wrote up box fill every single house, at least one, if not 10. I mean, I wrote up box fill constantly. And one of the things I thought was kind of cool was in 2013, I maybe wrote it up once. And it felt kind of good, you know. But it wasn't just me. It was the electricians. You know what I mean? They stepped their game up. They started thinking about it, and they realized this wasn't hard. You know, you don't just say, "Oh, I need a deep box." Well, what does that mean? You know, because they asked me if I'd write up. Well, do I need a deep box? Well, deeper than this, you know. I don't know what a deep box is, but what you need is 26 inches, you know. So do the math, you know, and don't look at the back of the box where it says how many wires. You know what I mean? Just do the math.
Oh, do they have
you know?
boxes?
Well, yeah. What it says though is that
You know, the
it'll say
industry
like,
is dumbing it down with
see,
people
it'll
are not
say like
responsible.
8 number 12. Okay, well then people stop counting the device and they stop counting. You know what I mean? So just do it. Count the hots, count the neutrals. All your equipment grounds is 1, device is 2. Do the math. It's so easy, and it's worth doing.
And if any manufacturers are listening, please put the cubic inches on the outside of the packaging.
Yes.
Because when I go into the big box store and I get a weatherproof box, the cubic inches are on the inside in the wrapping, and I have to unwrap it.
No way.
Yeah.
Are you kidding me?
Yeah, it's crazy. So if any manufacturers are listening,
my goodness.
please put the cubic inches on the outside of the box.
Well, you know, Ryan, you said something, and this is what I did when I was a young person and I was learning code. As soon as I learned something, it was like the lights went off, and I remember one time doing a voltage drop calculation. I just learned voltage drop, and at that time, we used rigid conduit for the plumbing, and they threaded the conduit, and they had to thread it and the whole thing. The plumber came up to me, and he goes, "Hey, how far can I put my threader so I don't have a problem with voltage drop?" And I'm thinking, oh my gosh, I just learned voltage drop yesterday. No joke, I spent 4 hours working that out. And I did it wrong. I did it wrong. Because the next day I'm like, oh, I'm sorry, I told you wrong.
Right.
Because I didn't understand how it all worked out. But what I'm saying is that I embrace, and maybe that's part of why I'm who I am today. I'm just a high school dropout kind of guy, and I got this guy next to me right here with Mike Holbrook, and he's a high school dropout kind of guy. But somehow we had a passion, and we started working with that, and we put it to life. So if I learned this box field calculation, and Mike would, I'm sure it's the same way him, then we would do what? I'd like, oh, let me go to my job tomorrow. Let me start counting the number of wires. Okay, a 14-gauge wire has 2 conductor volumes and a 12-gauge wire, and the device is this. And I would start calculating out all my boxes because that's fun. I would get a blueprint. I would calculate the conductor sizing and the protection, and I'd go through all those things. And I'd download that spreadsheet. I'm doing a short-circuit calculation. I'd start calling people up, and I'd start playing with it. And I'm sure 80% of the time I'd make mistakes. But I'm trying and I'm learning. So don't just take this as a passive thing like, no. You're the leader. You're the guy that's, my son, I mean, all you young guys, your guys are the leaders. We're leaving. Yes.
Oh, I just want to throw out there, since you're talking about it, as a business owner, when I have employees that take that initiative, I promise you, those are the guys that are getting their own truck and the promotions and the raises. Because I'm like, man, finally I have somebody that's going to do it without calling me and saying, hey, boss, what size box do I need?
Right. I tell you, when I was an electrician, I was a foreman, the owner never came to the job. Ever. And if you've ever been in that scenario, you're like, hey, man, you ever going to come by? Because you feel lonely. You feel like, come on, check me out. He goes, yeah, I'll get there. I'll be there Friday. I'll stop by. In other words, I felt it was my responsibility. If I'm the foreman on the job, I should be able to work with the owner or the project manager. I should be able to work with the inspector, the engineer. Why would I call my boss? I mean, that was foreign to me. That's why my job is, I'm the one that's supposed to be running the job. If they change something on the job, and I remember being on a guy's truck and all of a sudden, hey, boss, listen, it was supposed to be a 3-ton air conditioner. They brought a 5-ton air conditioner. What do you want me to do? How do I change the wire size? What do you want me to break her? Are you kidding me? You don't know how to size the wire to an air conditioner, to a 3-ton air conditioner, a 5-ton air conditioner, to a horsepower motor, change things? No. You need to know what you're doing. All right, let's go ahead and move on to conduit bodies. Some people think you can't make a splice in a conduit body. Yep, you can. You just need to know what the volume of the conduit body is, and then you got to know the volume of the conductors. So a 12-gauge wire has a 2.25 cubic inch volume. If this is marked 15 cubic inches, well, 15 divided by 2.25 gives you at least 6 conductors of 12 gauge. And 1, 2, 3, 1, 2, 3, 4, 5, 6. That would be fine to put the splice in there. So make sure you practice those exercises that we have in the textbook there. We just kind of do some glossing over here. Short L's or Jake L's or street L's. There's no cubic inch marked on that, and no, you can't make a splice inside those areas. 314.17, conductors that enter boxes or conduit bodies. Unused openings and cable openings in boxes. We talked about that in cabinets in 312. Now this has to do with boxes. You got to close them all up. Plug them in there, thread it in there. This actually is a house. See, mud daubers. I'm waiting for the mud daubers to fill that in there for me. And they're working on it, Well, I'm going to get to it. But that's just temporary. I'm going to get to that baby. Non-metallic boxes. Raceways and cables must be securely fastened to non-metallic boxes or conduit bodies by fittings designed for the wire method. We talked about cabinets. You got to secure raceways and cables to cabinets, but you had to have a rule in boxes that require you to secure it to the box, which is kind of like a no-brainer. And now, if you go into a one-gang box, you can bring the cable, and let's read it. Non-metallic cable terminating to a single-gang box isn't required to be secured to the box if the cable is securely fastened within 8 inches of the box. You guys probably don't even know what this rule is about. What this rule is, today if you buy a plastic box, does it have like a little finger on there? Right? You put it in there and it kind of secures it.
Some of them.
Yeah.
They usually they have some kind, right?
Yeah,
Some of
most
them
of them do.
Right? Oh, do you have some that don't?
Oh yeah.
Yeah.
It's just a hole.
Oh, just a hole. Oh, when that's the case, then it's just a hole. You just drop it in there.
Right.
You don't need a connector. You just drop it in a hole. But if you're not securing the cable to the box, well, then this rule applies. To the exception, then you have to secure. You have to bring it in a 1/4 inch to the box, and then you have to secure the cable within 12 inches.
Yeah. This is reality.
I did not realize
that's
that they
all I
made
see.
boxes today.
That's all I see.
Okay. Really?
Yeah.
No little finger thing that you
No.
slide in and
I,
locks?
I know what you're talking about. That kind of springs back.
I think Slater or something
Yeah.
like that?
This is what I see.
Wow. Okay. Recess boxes in walls or ceilings. Well, if it's similar to cabinets, if it's non-combustible, you can recess it a 1/4 inch. Boxes, plaster rings, extension rings, or listed extenders must have the front edge set back no more than a 1/4 inch from the non-combustible finish. So if you end up having that box, they change the thickness of the wall, right? Now your box is an inch further behind the finished surface. Just put an extension ring, and then or change the plaster ring, whatever the case may be. If it's combustible, paneling or some kind of wood, then we need to make sure that that box or the extension ring or the plaster ring is flush with or protrude there or projects there out in front of that. Because obviously we want to make sure that we have no way to have combustible products in that cover. Yes.
I'm just going to ask a question because some of the guys out there might not know this. It probably would be a Ryan question, but is sheetrock combustible
Love
or
it.
not?
I've got that a lot.
Really?
And what I love about
Come on. I mean,
I don't know who these people are
come
either.
on.
I mean, that's what you make fire-rated assemblies out of, right, is gypsum. But what I like about this is right in the code, thankfully. It says, in walls or ceilings with a surface of concrete, tile, gypsum, plaster, or other non-combustible material. So right there, gypsum, what we call drywall is gypsum board, gypsum. So no, gypsum is non-combustible.
Okay.
And don't give me that nonsense about, it has a paper face on it. Gypsum is non-combustible.
Is that why you asked that?
That's why I asked that. I've heard it numerous times. I've
here.
actually had inspectors that have attempted to turn us down for that.
Oh, because you're saying that the drywall has some paper on it, and so that's considered combustible.
I had an inspector go so far as to pull his lighter out and tear a piece of paper off and light it on fire.
You don't think that
Tell them to light
burns?
the rest of it.
Yeah. I'm serious.
See you next week.
All righty then. I didn't have any clue what you were asking that dumb question.
I was actually
gosh.
going to ask the exact same dumb question, and I put my hand down, and I saw his go up, and I was thinking, I wonder. That, yeah.
Wow, it's amazing how some people could, but I mean, I can see somebody, it's reasonable to think that the paper is combustible, you know what I mean? But you're saying the code, gypsum?
It's gypsum.
Yes, I'm sorry, Victor.
Where you're going now,
Uh-oh.
and where you just came from, you said change the plaster ring.
Hold on. Right.
How do you do that without messing up where we're going to?
Well, what the code is saying here
Right.
is that if you're having wood, and you know this in advance, one of the options is to change your plaster ring. If it's already done, then you use an extension ring or a goof ring or whatever you want to. So it's a matter
You're talking
of
about one of those that fits inside.
Yeah.
Yeah, okay.
yeah, you have those that it'll fit
Okay.
inside. Now that's not a plaster ring.
Correct.
That's an extension ring. No, it's
Okay.
not an extension ring. It's a listed extender. Is
Okay.
what it amounts to.
A listed
So
extender.
if you
Okay.
know, hey, listen, they're going to be finishing up this wall. I've done before where I put like 1.25 inch plastering on something because I know that we're going to do this
yeah.
and then we're going to. Then I do that. So yeah, you probably wouldn't want to go to an existing building that you're already now an inch deep, and now you have a combustible material. Just use the extenders,
Extenders, yeah.
and they don't have to be metal. They make
Correct.
them non-metallic.
Arlington makes a great plastic right now.
Arlington, man,
Yep.
Fantastic product.
is that right?
Oh, yeah. They're
I mean,
great.
I remember, I would get the metal extenders, how they were cut on the side,
those things
and
scared
I
me
would
to
be like
death.
terrified. I'm thinking, I just don't feel something is right about this.
Oh, yeah.
But I mean, I put them in, right, Mike? You remember that?
This is going to blow up.
You have to tape the receptacle first, though.
Yeah, you have to
Oh,
take
yeah.
the receptacle. You're terrified that,
Anytime
oh
I take
man,
that.
I hope
Yeah.
this thing doesn't blow up on me. You know what I mean? And
Yeah.
you're saying, you know, then I've seen they come out with a plastic. They're simple, little tiny plastic sleeve.
Yep.
You set it inside there. Wow. How long does it take? 100-something years before somebody could think of something like this? That's nuts. 31421, repairing plaster around boxes. Repairing gaps around boxes. If you have a gap around a box, if it's greater than a 1/4 inch, you got to patch it up. I'm thinking, okay, call the painter. An 1/8 inch, greater than an 1/8 inch. Surface extensions. We wouldn't think you need a rule on here, but I guess you do. If you want to make a surface extension, so you have a box that's recessed, and you want to make an extension, well, put an extension ring on it, and then come off with the extension ring with the wire method. We're like, okay. I'm like, why are you telling me that? Well, I just want you to know. I'm like, okay. But there's another way of doing it, is that if you have a recessed box, just put a cover, and then have your flexible wiring method connected to the cover. You just have to make sure that that flexible wiring method is going to be required to have an equipment grounding conductor, because obviously you're going to take the cover off, and you'd lose that equipment grounding path. Box supports. I always find it fascinating supporting of boxes. This is one of those things that, man, it's amazing how creative people can be. It really, truly is amazing. And, a simple thing of supporting a box, the code has to get into as much language as it possibly can, and it's still not good enough. So let's take a look at 314.23, support of boxes and conduit bodies. Boxes can be fastened to any surface that provides adequate support. So there's your general statement. If it's considered adequately supported, then you're fine. And it's going to get into some specifics. It's questionable whether supporting a box to a tree is considered adequate support. Now, I'm not purposely trying to show you all the code violations on my house. You know what I mean? I'm just saying it happens to work out that way. But many, many years ago, I put a box on a tree, and I made sure I had flex, because I figured the tree's going to flex. I did not know that when you put a box on a tree, the box doesn't stay there. The box goes up. I thought the tree went out. I don't know. Listen, I don't know. I don't work with trees. But the box actually goes out a little bit, but it does what? It goes up. Now I still got the thing in the tree like this. We got my other house, and look what happened. The only thing I had lucky was what? I had a strap on the liquid tight. That's the only reason why it's still hanging there. So I'm not sure about this whole tree deal. Supported boxes and conduit bodies. Let's talk about structural mounting. Boxes can be supported by metal, plastic, or wood braces. Metal. That's a nice job, right? It looks nice. Wood. Okay, it's good. And here's a brace. I think it's kind of cool. Does Arlington make this thing also? I think it's a cool little guy right here. I saw that. It threads in the back of a weatherproof box, and you put a piece of rigid conduit.
Rayco and Thepit. That's Rayco and Thepit, Steel City.
Yeah, that's kind of cool.
Arlington does too.
It looks nice. Of course, this whole thing's going to get all broken and destroyed anyhow, but the concept is nice, And here's a box that's just out, in the middle of the free air. Obviously, that's not good enough, right? Because boxes have to be secured to something at least. And this is just sitting out. You know what, guys? Let's go we're going to go here for dinner tonight, all right? We're going to go there. We're going to Mexican.
Is that conduit growing a tree?
Yeah.
Now, this is just a little decorative plant to make the pipe that comes up. See, there's a pipe that goes up here, and there's a pipe that goes over here. Tonight, we're going to go to dinner. We'll stop there.
It turns into plumbing.
Okay? Did you guys see that?
I'm not sure that I want to go there.
Oh,
Yeah, not
Am I
like it.
gonna
It's
live
great
to
stuff.
tell
the
the
place that
tale?
has the flan, right?
This is the kind of restaurant you really want to eat at.
Oh, yeah.
All right?
Yeah. Yeah. They concentrate on the food instead of the electrical.
There you go.
Yeah, good point.
Here's a box. That box is not supported. These are actually alligators. So here's a box there.
So that box might be supported.
I tried to look for that. I could not find it.
Yeah, that might be supported.
You could try to find that. I looked at 410 on that box. I looked at the rules
yeah,
there.
it's the 31323F. I don't know if it meets it or not.
All right,
but
let's read
there's-
to me. 3 what?
Oh, I'm not reading it. It's a Hartwell rule.
I know it's a Hartwell rule.
It's a page and a quarter. I'm not reading it.
Fred, I love you if you're watching this right now live. We love you. And I would say it in front of your face, okay? When you write code rule, man, it covers every possibility. Hey, you know, Fred, thanks for that 404.2, was it 2C? Thanks, Fred, for bringing that neutral at the boxes. We're still struggling with that thing there. Okay, yeah, this, by the way, this is a hazardous location.
Yeah, really.
Okay, box. Okay, you want to read me the rule? What rule? So the guys that are at home and the DVD and our streaming
Well,
guys can go to it. What is it?
It's 314.23 is our box support rule. And then you have F, which is for raceway supported enclosures that contain devices, luminaires, or lamp holders. So that one would be a box with a luminaire supported by a raceway. And then basically it has to meet the criteria that's quite long to read. I'm trying to be really nice here, you know. But I mean, if it meets this, then it works, and it could. You know what I mean? So me as an inspector, I'm like, you know what? Probably meets it. I don't know.
Are you going to go out
I
there
don't know
and
how much
measure?
time I have here.
I
you
don't
know?
have the time to go.
Oh
to
yeah,
it.
yeah. I'm gonna go measure that. You know. Oh yeah, let's check that out. You know. Kick those alligators out of the way.
You know, I looked at that and I couldn't. You know, I gave up the same thing. So I just okay. So this is I'll have to.
that could meet
It could 3:14:23
F.
F.
Yeah.
Hey, streamers, those of you guys at home watching this right now, Don, you guys go through the whole thing, do some work inside there, and let us know if it meets it so we can keep going and recording, and then we
See
want
it
to
in
know
an hour.
what's going on the answer. We'll try to give you the answer before you leave 3:14. So we got guys that we're streaming this live on the internet, and so there are people that are watching. We don't have the time to screw around with 3:14:23 F. F, is that what it is? Okay. All right, we're
F
moving
exception.
on. Let's go to 3:14:23 D. 1, framing members. We talked about that previously. Boxes can be secured to the ceiling support. The framing members, ceiling framing members. So you're okay to do that. Independent support wires. Boxes can be supported to independent support wires. Let me see, Mike. I think that wire, that box. I want to say, all the boxes can be secured with independent fittings to the ceiling and the ceiling support. Hey, Ryan, is that double checking? I can mount a box to the actual ceiling support wire?
To your own.
No, check it. See if the code says to the ceiling and independent support wires. Oh, okay. I'm sorry. To the ceiling. I can mount a box to the ceiling right here.
To the grid.
Or I can mount it to independent support wires.
Independent. So yeah.
So
that
therefore,
that should be blue.
we need to make sure that we need to move this box over to a blue wire.
Right.
Because the blue wire is what we're using for the electrical. So I cannot add it. So that, I don't want to call it as a violation. I just want to show it where it's properly installed on there. Oh, I think this is interesting. If you have 2 threaded entries into an enclosure and you support that within 36 inches on 2 different sides, then that box is considered supported by the support of those fittings. If you have 2 threaded entries on the same side, oh, by the way, this rule right here, you cannot have any devices, luminaires, no equipment on it. This is just an enclosure. But more than likely, you're going to have something in it. So if you have a box with 2 threaded entries on the same side with a maximum 18 inches of support, then you could put a receptacle or a luminaire, and that would be okay. The reason this is a violation is because the rule is 2 threaded entries. And I think I'd like to make this graphic probably with threaded entries and make it okay because I got enough graphics showing violations. Here is a New York City in a park, 1 raceway. That's a violation. I really like that photo I took. That's in Destin Beach, Florida. I mean, I think that is just a gorgeous installation. Unfortunately, what? How did you say, Ryan? That's a beautiful code violation?
That's a beautiful code violation.
Yeah. Because it's what? A single threaded entry. I always find this fascinating that you can support a box by a flexible cord. But when you do that, we probably should show a box over here, which is a 4-square box, and show a violation. Because you can't take a 4-square box because the box has to have a hub. And therefore, you have this, basically it's going to be a weatherproof, but it's a threaded entry. It's going to have a hub. and then you'd have a pendant cord, and that would be fine. Yes.
Necessarily be a weatherproof box. They also have boxes that are specifically for hanging from cords. Daniel Woodhead makes a very big variety of different rubberized boxes that don't bend or crack or break.
Oh, really?
Oh yeah, they're fantastic. We use
What's
them
that? Hold
for
on.
control
Let me down there.
pendants a lot.
These are plastic enclosures?
Rubber, actually a hard rubber enclosure, so if it gets banged by something, they have flexibility to them.
Oh, that really makes a lot of sense. So they make an enclosure that is rubber.
Rubberized, yeah.
Rubberized, yeah, I understand what
Yeah.
you're saying. And it has a threaded entry,
Yep.
and therefore you would put the threaded entry, and then you would have the strain relief in there, and you'd have your pendant cord, and you do whatever you're going to do. And it can be used for
Specifically
crane control.
designed for it. We use them for crane controls. We use them for start-stop stations, for remote start-stop for equipment, that type of stuff.
Wonderful. Good stuff. Ryan?
You know, I always read that as mandating a hub as well, but it's funny when you actually read it. A box shall be supported, this is H1, from a multi-conductor cord or cable in an approved manner that protects the conductors against strain, such as a strain relief connector threaded into a box with a hub. So that's one example. Doesn't necessarily need to be a hub, though.
But for sure, if I thread it into a box with a hub, I'm
Right.
okay.
Right. Yeah,
If I don't, I need to get the authority having jurisdiction to approve
then you
it.
got to debate.
Yeah, okay, good. 31425, this is an easy rule. You know, when you have a box, you got to put a cover on it. You got to put a faceplate on it. You got to put a lamp holder. You got to put a luminaire. And I learned what a lamp holder is. It's a keyless fixture. It's the most practical thing to put on an outlet box. So one way or the other, when you have a box, you got to finish it up. And Ryan, you talked about that. You cracked you up. Big, massive house, and they run around, they put 25 keyless fixtures all over the place because somebody thinks you have to have a luminaire. No, you have to have a lighting outlet, not a luminaire. You have to have the box, however, closed up. Wait a minute. Do I have to have receptacles put in?
Oh boy.
I mean, if I don't have the light, do I have to put in switches? I'm just thinking. All right, we're going to keep going while
Yes.
you guys are like,
Yeah, 210.52 says the receptacles required by this section.
shall be installed. And you need receptacle outlets, and a receptacle outlet can only occur when you have a what in it, per Article 100.
A receptacle.
You need to have a receptacle in it. If not, then you only have a what? If you have no receptacle in an outlet, then you don't have a what?
A receptacle.
You don't have a receptacle outlet.
I have an outlet.
So you need receptacle outlets, and you need lighting outlets, but a lighting outlet, do you have to have a luminaire on a lighting outlet to make it a lighting outlet? No, you just need to have it at a location that but we didn't talk about this, but when you have a lighting outlet, the box has to be identified for the purposes of hanging a luminaire fixture to the box. That's going to be your 832 screws. A paddle fan, that's in the book there. You'd have to have a box that's designed for a fan, which is going to be your 1032 screws. And then, of course, it gets some more details. We're going to talk about that when we get into 410, Chapter 4. Let's move on. All right, 314.25 continuing. New 14 code says screws used for the attachment of covers or other equipment to the box must be machine screws that match the threaded gauge or size of the screw holes in the box. In other words, sheet metal screws and all wood screws and everything else are not permitted. Metal faceplates, where used, must be connected to an equipment grounding conductor. You know, the code doesn't describe how to do this, but simply putting a metal cover on a metal box automatically takes care of having the metal faceplate connected to an equipment grounding conductor, even though it doesn't specifically say that. But clearly, we probably maybe want to show a graphic inside here. You can't have a plastic box with a metal cover plate because there's no way to connect the metal cover plate to an equipment grounding conductor. So metal boxes is not a problem with metal cover plates, but plastic boxes are a problem with metal cover plates. 314.27, outlet boxes. We talked about that previously. A luminaire mounted in or on a vertical surface weighing no more than 6 pounds can be supported to a device box or a plaster ring. You see, a device box is designed for a device, like a switch or receptacle, and the screws on the device box is 632. So you can't put a luminaire on a device box because the box was designed for devices. But this rule recognizes that if you're going to be on or in a vertical surface, that you can use a device box as long as the luminaire does not weigh more than 6 pounds. So we can probably put on this picture here, not more than 6 pounds. And then you'd be okay to put that on the device box. Lighting outlets, I mentioned to you earlier, in a ceiling must be designed to support a luminaire weighing at least 50 pounds. So when you get a box that's designed for a luminaire, it will automatically be listed to support 50 pounds. So there's nothing involved inside there. If the luminaire is more than 50 pounds, then you're going to have to get a box that's specifically listed for the weight of the luminaire. And if it can't get a box that's listed for the weight of the luminaire, then you would have to independently support that fixture from the box. Now, I was at one of the big box stores, and I was looking at some of the paddle fan boxes. And the paddle fan box, and there was like a lot of, I mean, my gosh, this is like a whole row, the boxes inside there. But the paddle fan box, I noticed some of them were, I can't remember what the fan weight was marked on there, but they had different weights of fans, and each of those fans had different weights for lighting fixtures. And there was a fan box, I think, for a 70-pound fan, and it was marked on the box, listed for a 140-pound light fixture. I did not know. Simply go into it was in Lowe's, and you'll see. I tell you one thing, the box manufacturers, even though Eric, you had some problems, you're labeling in cubic inches, and some of this and like that. But these guys that are selling the fan boxes, they're doing an amazing job giving a lot of information on the outside packaging. And I thought, wow, 140 pounds for lighting fixtures, 70 pounds for a fan. So that's information that I wasn't aware of. Maybe they make even boxes that supports more than 140 pounds. Brian, do you know if they make anything like that?
Oh, yeah, they definitely do.
Really?
We actually run into this pretty frequently at our Naples office because we have houses, obviously, with real large crystal chandeliers, and crystal is very heavy.
Really?
Yeah.
But where do you get these boxes?
Believe it or not, and obviously Naples, because they're used frequently, they're readily available. So supply house.
But I mean, what manufacturer? I mean, is there...
There's a number of them. The ones that we use for the real big chandeliers most frequently are made by Aladdin because they're typically on lifts, so you can lower them to clean them.
Okay, so they're available.
Oh,
Do
yeah.
you know how much weight they're available for?
The ones we put in frequently are a 200-pound.
Really?
Yeah.
All right. All right, continuing on boxes 31427B, floor outlet boxes. Floor outlet boxes must be listed for the purpose. What I didn't know is I knew you could get a floor outlet box, and I've done those for many, many years. But I had a piece of property, it's like 80 years old, and it's in a crawl space, and it has all plaster walls inside there, and I was going to put some air conditioning units inside the outside walls, and I thought, you know what, I'm not going to sit there and destroy the plaster walls. I'll just cut a 4-square box, put a work box in the floor, put a receptacle, is what I did, and hooked it all up. I didn't realize that the code requires that when you have a floor box, it must be listed. And not only that, but they make floor boxes specifically for wood floors as well as concrete floors. So, as Ryan, we were talking, and Brian, as we were talking about, as the electrical industry, we really got to learn what the products are available out there. Get EC&M magazine. If you're not going to read the articles, at least look at the pictures. You know what I mean? Come on. You know what I mean? Just get into the information. Let's go to 31427C. Fan outlet boxes must be listed, marked as suitable for the purpose, and they cannot support a fan that weighs more than 70 pounds. If it's more than 70 pounds, then the box, panel fans over 70 pounds must be supported independently of the box. Now, I'm going to have Mike add a graphic, and there was some discussion before we actually went live on the recording of the DVD about what about putting a paddle fan outside in a wet location. Apparently, the company called,
Garvin.
GARVIN Industries makes a wet location paddle fan box. So if you're in a wet location, let's say outdoors. Now, I'm not talking about under an eave or under a canopy. Under a canopy is going to be a damp location. Ryan, help me out here. If I'm in a damp location, what kind of boxes can I use in a damp location? Do I have to use a wet location box? Is there such a thing as a damp location box? I'm in a damp location. I know if I'm in a damp location, we'll talk about this at 410, I got to use fixtures that are listed for a damp location. And I think we're going to have to go to boxes in damp and wet location.
314.15.
314.15. What's that say?
In damp or wet locations, boxes, conduit bodies, and fittings must be placed or equipped so as to prevent moisture from entering or accumulating within the box, conduit body, or fitting. Boxes, conduit bodies, and fittings installed in wet locations must be listed for use in wet locations.
Okay, so I don't have to use a wet location box.
Yeah, we just have to
in a damp
prevent
location.
moisture from entering.
All right, so therefore, if I'm under a canopy,
Bubble gum over the holes, and you're
if
done.
I'm under a canopy, right, I can use a regular paddle fan box in a damp location. It's only if the fan is actually in a wet location. What was that guy called? What did you guys call that thing when you have the wood beams?
Pergola.
Pergola?
Yep.
I call it an arbor. We have one in our house.
Yeah, like an arbor.
It's just
Similar.
like beams, it's just a wood, just some beams out
Yeah.
there.
Yep.
Like a truss.
Yeah, just some wood out there, and it's kind of decorative. A lot of times you see in the Southwest, they just have some beams outside, and probably in the Northwest it's the same thing. And so now, obviously, it's open. So if I put a box up there, I put a fan up there, that's a wet location. Now, you read 314.15, was it C?
Just 15.
15 says, well, in a wet location, you need to have a wet location listed box. And when you get the paddle fans, you need a paddle fan that's listed for paddle fans, and they do make a box that's wet location listed for a paddle fan. So that's what we're going to have to use. Okay? Let's move on. An interesting rule that if you run a spare wire to a box, is what it's saying, at a location where you might put in a fan, then the code says that the box that you're going to use is going to have to be listed as a fan use. And the thinking is this. A guy runs 3 wires from a switch up to a box. He puts a light fixture. But later on, they decide they want to put a fan. Well, there's a spare wire up there for the switch leg for the fan. And so therefore, they want to make sure you have a box that's fan. Now, other people are saying, no problem. I run 2 wires up to the switch up there, and I just put, one of those remote control switches, right? You put that inside there, and you hang the fan, and you control the light at the same time. So we're really not getting anywhere here in that thing. In other words, if somebody could put a regular light box in a location, but later on they can hang a fan, and they can control the switching of the fan with a remote control without putting a spare conductor in there. So those of us in the trade, we have to recognize when you hang a fan in a box, the box you hang the fan in must be a fan-rated box. This is not something that, this is really, really important because fans do fall. As a matter of fact, I got a call recently where a fan just fell down. I think it was like in a restaurant. So even though the code says, well, if you ran a spare wire, make sure the box is fan-rated, maybe it's something you want to think about even where you're not running the spare wire, not code rule. This is now we're getting into design. You might want to make sure the box is fan rated. That's all I'm trying to say here. Let's move to 314.27D exception. It says that you can use a device box or a plaster ring to support equipment by the 632 screws. And when they say equipment, they're really talking about the smoke alarm. But is that the right word, Ryan? Smoke alarm? Talking about the smoke alarm. Because technically, in the way the years passed, well, this was only supposed to be, for in the ceiling, it would have been you don't put a smoke alarm or it's a receptacle. Right? Yeah, it's a device box. Right. So now you can, not now you can, but I mean, it makes it clear you can do that. 314.28, boxes and conduit bodies, 4 gauge and larger. This has to do, if you have 4 gauge and larger, then you're going to be doing straight pulls and angle pulls. You might be having LB conduit bodies, and then you might be doing U pulls. And there's a big formula involved here to make sure that you get it sized properly. Let's take a look at it. A straight pull means you're coming conductors in from one raceway going out the other raceway. Now, this is one of the topics that when I teach, it's possible you will get it, and then when you blink and you wait and you open your eye, and all of a sudden you get confused. This is an easy thing to get, but also an easy thing to forget, and they get confused. So I'm going to try to keep it simple and clean. If you have a straight pool, and I've done this before. I one time went to a job that they'd slabbed the panel in this one wall in the PVC, but then when you looked inside the room, when you looked in the ceiling, all the raceways were stubbed on the other side of the room. How many of you guys know what I'm talking about? So the two guys that did the ground floor slab and the guys that stubbed all the pipes didn't connect the two. I'm looking at that, I'm looking at this. I have two choices. Run all the branch circuits over the panel on one side, or guess what? Get a wireway, straight, right? Make a straight pull, and then go ahead and take it over to the panel board. Now what I did was, I went ahead and I did a straight pull. It was a 2-inch raceway, and when we followed the rules, let's take a look at the rules, and we'll maybe make a graphic like this here, is I had a 2-inch raceway coming in, and the rule is 8 times the largest raceway. So in this example, it's 3-inch and 3-inch. It'd be 8 times 3. I'd need 24 inches from this entry of this wall to the opposite wall. That would be 8 times 3. In my case, I had a 2-inch raceway coming in. I put 8 times 2 is 16 inches. Well, you don't buy a 16-inch 4x4 wireway. I don't remember what it was. Probably was a 2-foot 4x4 wireway. And then I ran the PVC up and over in 290s. And when I pulled the wire, I went ahead and I pulled the wire up from the panel over into the to the pull box, right through it, and I pulled the wires right through the whole thing. See, the code says the maximum distance between pull points is 360 degrees. It doesn't say you can't put a box in a straight pull box inside here and pull 540 degrees if you want to pull 540 degrees. Okay? Now, but let's just assume that I was pulling it into that room, and then I'm going to pull it and feed it out of that room, and then take it back up into the 4x4 wireway, which mine was 2 feet long, and to feed it back in again. Watch what was happening. I pulled it and I have what? A 90, and then I have a 90, and then I have a 90, and then I have a 90. So I have it looking like this here. So I had to have enough room to accommodate 90, 90, 90, 90. And that's where the 8 times the largest raceway comes in place. I want you to understand there's a formula that's involved inside here. How far you separate the raceways that when you're going to be pulling straight through. 8 times the largest raceway. Look back at the graphic. And that's the rule there. Victor?
That's the code rule, and you can't go any smaller than that. But I guarantee you, if you go a little bit bigger, you'll save money because it'll be easier to pull in.
Is that right? A lot easier than trying to fight.
That's the worst
It's
pull
right.
in the world.
It's like
Right.
it's
That
like
is
I
the
mentioned
worst
earlier.
pull.
You would never want to go 40% fill on a raceway.
Right.
You're telling
Yeah.
me you don't want to figure 8 times the largest raceway
No.
on a pool.
Yeah.
Okay, you have the expert, Victor. If I had a 2-inch raceway, beside 8 times, not we're talking design now. He's an expert here on design. What would you kind of like to see? That 8 times, 10 times.
Well, it's going to be a feel. What are the conductors you're pulling in there?
Okay.
Actually, because
how long is the
it's-
pull going to be?
Yeah, how long is the
What
pull?
size conductors?
What's the size of the conductors?
Okay, all right.
You know,
You're just
it's
saying,
gonna
listen,
vary.
you want the guys in the DVD to understand, you know what, give it an option, make it bigger.
Yeah.
You won't be sorry.
Yeah.
Brian?
Well, I was just going to say, from a practical standpoint, you really don't want anything less than a 24-inch junction box, just because there's not enough room to move your hands while you're trying to pull the wire. You're just going to tear your knuckles up. And I mean, I'm sure there's design standards you could come up with, but just think about it, you have to pull the wire.
And 2 feet
It's not much.
is not much. Okay, great stuff.
And there's also another reason why you would never use a conduit C in this. But I've seen that happen.
Oh, yeah.
Some people put a conduit C in there.
Well, hang on. Not everybody knows what a conduit C is. What's a conduit? Because we have LBs, and now we're having a C.
It's just a straight with an opening with a cover, and that's great for 6 gauge and smaller.
Right here?
Yeah, but
You're
not
saying,
for 4
you
gauge and
might
larger.
not want to go 8 times the largest racer, because of what we just talked about. All right, let's go on. How about angle pulls? That's where conductors are not being straight pull. See, it's real simple. I mean, if I don't have a transfer marked with a class, it's class 1. If it's marked class 2, it's class 2. If it's a straight pull, it's a straight pull. If it's not a straight pull, then it's an angle pull. I mean, there isn't any other option here. So that makes it kind of nice. Let's look at angle pulls. Angle pulls is going to be measured on 6 times the trade diameter of the largest raceway plus the sum of 3 and a 2 and a 3 and a 2. So it's going to be 6 times the largest plus a sum. So A and A would be 6 times 3 is 18 plus 2 is going to be 20 inches. That's from this wall right here to this wall right here. It's going to be across. Vertically, 6 times 3 plus 2 is 20 inches. And you're saying, yeah, okay, maybe a 24 by 24 might work, but you wouldn't be sorry if you made it bigger than a 24 by 24. Okay. U-pulls. That's where the conductors obviously are not coming as an angle. I mean, it's not a straight. They're kind of like, there aren't many things left. They go up, over, and down. And it's you size the same way. 6 times the largest raceway from an entrance to the opposite wall, plus the sum of the other raceways. 6 plus 3 is going to be 21 inches from this entry to the other side. Well, Mike, we'll talk about separation. I'll talk about it right now. Raceways containing the same conductor cannot be less than 6 times the tray diameter of the largest raceway. So from this edge here to this edge here, I'm getting ahead of myself here, that cannot be less than 18 inches. Just giving information. Now, if you're making a splice, then, and let me go back here. Let's take a look at this angle pull. Let's look at the math here. Angle pull, ready? And it's going down. I have a 90, right? I have a 90 coming in, and then I have what? A 90 going down. So it's not 90, 90, 90, 90. It's just 90 coming in, 90 going around, and then what? 90 going down. And then it kind of rolls into the box. And that's why it's 6 times the largest raceway plus some of the other raceways, which being said, because you have another raceway, you might need to move it over a little bit so that you can accommodate the conductors of the others. Let's go to a U-pull. Well, a U-pull, wires are coming out. I make the 90 outside, and it what? And it goes in that direction. So I need to have enough, 2 90s. So angle and U-pulls are 2 90s, so it's not 8 times the largest, 6 times the largest, plus the sum of the others. When you make a splice, well, look at the splice. I'm pulling it in. That's it. There's no 2 90s. The other one, pull it in. So when you're making a splice, then we don't have the sum of the others. I mean, we would have the same of the other. It's going to be from the right side to the left side, A, dimension, is going to be 6 times the largest raceway plus the sum of the others. And from the bottom to the top, 6 times 3 plus 3 and 3 is 24 inches. Just like an angle pull. It's not a straight pull.
Right.
Oh, well, there you go. Now, you got all the rows. If you have this row and you have that row, well, just get the biggest row. If you got a 3 and a 1 and a 1 and a half, 3 and a 1 and a half and a 1 and a half, and you got 1, 1, 1, well, then this is bigger, this row. Well, then 6 times 3 plus 1 and a half and 1 and a half. 6 times 3, 1 and a half, 1 and a half. 21 inches from one entrance to the opposite wall. And, of course, we would have those same raceways. Oh, well, here they are right here. I'm sorry. And then from this top wall to the bottom, we need to put on here 3, inch and a half, an inch and a half. Then that would be from the top to the bottom, 6. Oh, the largest row. It looks like okay. Using this dimension A would have been 21. And this other row right here would have been 6 times 1 plus 1 and 1. That row for dimension A would have been 8, of course. We go with the largest of the two. Just showing dimension A only in that example. Distance between raceways containing the same conductors. If this is a 3-inch and a 3-inch, well, the edge between the two raceways are 18 inches. It's edge to edge, because if it says the distance between raceways, well, obviously not the center of the raceway, but between raceways. 2-inch and 2-inch, well, between the two raceways, 6 times 3, it's going to be 12 inches. When you're bringing a raceway out the back of an enclosure, now these rules apply to boxes as well as conduit bodies, that when you come to the back of an enclosure or conduit body opposite a removable cover, well, that's a totally different ballgame. Now we're talking about bringing in a conductor, putting in 190, and then putting it into the enclosure. When we get done with it, we just need to have enough bending radius that would be required just for the bending radius of the conductor. And that references back over to 312.6a, using the table that uses 1 conductor per terminal. So you're going to kind of go to table 312.6a, you take a look at it, you find out what size conductor, and let's say it was 500 kc mils, and it's going to be 6 inches. Is that right?
Oh, I thought it was 4.
Yeah, I think it's 312,
Oh, it
that's
is
6A,
six. It is
right?
6,
One
yeah.
conductor per turn, was that 6 inches?
Yeah, 6.
6 inches. Same thing with the conduit body. I mean, if you enter to the opposite wall, well, if you can get 6 inches conduit body, well, okay. But more than likely, conduit bodies are probably not going to meet the requirement that you need as it relates to pulling large conductors in there. Now, the rules that we just talked about, an angle pull is what? From entrance to the opposite wall, no less than 6 times the largest raceway. 3-inch conduit body, I need to have what? 18 inches. But the 3-inch conduit coming in on the side, opposite removable cover, well, what's the largest conductor that can be entered in that? And what's the wire that you have to bend? And that might be 6 inches. So they do make conduit bodies that are very, very, very long to accommodate this. But most people just buy a regular conduit body. And Ryan, give me the exact reference. I think it's 31428A. There's an exception in there that says that conduit bodies don't have to comply with this if they are marked with the size of the conductors on the specific conduit body. Maybe it's not an exception. Maybe it's now just a rule. So Ron, 31428A, what's the rule on that? What's the rule number?
A3,
Yeah.
which says listed boxes or listed conduit bodies of dimensions less than those required in 28A1 and A2, which we're talking about, shall be permitted for installations of combinations of conductors that are less than the maximum conduit or tubing fill allowed by Table 1 in Chapter 9.
All right, let me explain what that is saying. That is saying the manufacturers are making these regular LBs. A guy who's a regular electrician, like me and anybody else, hey, I've got a 2-inch, 3-inch, whatever it is, I'm pulling in 500 thousandths, you get the LB, and I remember doing this one time. You get the LB, and no big deal. You go to pull the wire, Victor, and all of a sudden, you got the wire in with a little bit of work to get the wire in, and you get the wire going in the other direction, and then it gets to be a little bit of a problem to get those 4 conductors in the LB. So, Victor, here's what you do, in case you guys don't know this. You go and you get a truck, and you put it in gear, and you connect to only one wire, and you get a 2x4, and you get yourself a sledgehammer, and then one guy holds the 2x4 onto the 500 thousandths. The guy has it in gear because we don't want to give it gas. We just want to have a nice little gear in there, right? Maybe adjust the carburetor a little bit, maybe get the speed a little bit, just a little bit. And then you get the 2x4 holding on that, and then you get a hammer, and then the sledgehammer, and then you tap it. And you'll notice it'll go in like a ½ inch, a 1/4 inch at a time. Boom, boom, and then all of a sudden it'll pop. Then you got the one. And then you get the other one. I'm telling you how. And then you get the other. And that's when you realize something is not right here because that was really hard, and I'd never want to do that again. Now, Victor, tell me, is that kind of something that...
Oh, yeah, you got it exactly right.
So, what's the deal with 31428A3? That's the rule that allows the manufacturers to sell an LB that we can't use. By them putting in the wire size and number of conductors, it makes it a legal listed product. We never said that you could put those kind of wires in that LB. We said it was good for 3/aughts. The fact that you put it on a raceway and you ran 3/500 thousandths, I'm sorry, you did not use that product. So my point is this. They make conduit bodies. They mark the number of conductors and the size because that would be the proper size conductor. But we're not aware. You can't use that product if you don't comply with the size of conductors, which means leading up to what we were saying earlier, you really cannot use an LB unless you get what? Those that are specifically designed that are much larger. So you have to go to 31428A1 and A2 calculations. There is no other option. And if you do that, the conductors get pulled in. It's going to be a safe installation, and that's what we're supposed to do. Hopefully, you only do that one time, and you're not that dumb to do it again the next time. Then you come up with other techniques and maybe getting the proper size conduit body, and they do make them really, really long. Okay? I'm glad we got that covered. 31429, wiring to be accessible. Well, I love these kind of rules. Pretty straightforward, can't be complicated. The wiring must be made accessible without removing any part of the building or structure or excavating sidewalks, paving, or the earth. Now, this has to do with boxes. So the wiring in a box has to be accessible. Of course, you have lift-out panels. That wiring is accessible per Article 100. Same thing when it's going to be in a raised floor. That wiring is accessible. Clearly, That wiring is not accessible because the scope of 314 includes what? Conduit bodies. Handhold enclosures, 314.30. Article 100 defines what a handhold enclosure is. That's something you put your hands in, but you can't physically get inside. Handhold enclosures must be identified for underground use and be designed and installed to withstand all loads likely to be imposed. Those of you that are watching some of our books and graphics, once in a while you'll see a character in here, and this character is our mascot. This guy is called Wilson, and you can't see this because the cameras are fixed, but Wilson is sitting on top of the camera right next to me that is actually shooting the angle showing the four guys over there. So we have like a little mascot, and so every once in a while, you know, Mike Colbert, he took a picture of Wilson, and Scotty, my camera guy here, he's a little strange. You know what I mean? Whatever reason, he makes Wilson up, and so we kind of follow his lead, and we take pictures, and then Wilson kind of follows us, and that's where it's at. So what I'll do is I'll make sure I'll get Wilson down. Can you get Wilson down, or is that a problem to get him down? Yeah, he's going to get Wilson down. Okay, so I figured there's a good reason that you know the story. Somebody else reading the book and not knowing the story here won't know why Wilson's there. So while we're working on Wilson there, we're going to have Victor. Anybody want to say something, Victor, at all?
Yeah. There's no specific size for a handhold enclosure.
Okay, what is the definition of it?
It says you can't get in it.
Okay.
Right.
Okay, it says that you cannot get it.
I mean, I've got projects going on right now where a handhold is 4 by 6 by 4.
Oh, really?
Yeah.
Oh, I didn't think about it being that big. All righty. And that is Wilson. All righty? Wilson, you can say hi to these guys. All right. Wilson, you go back to work. Get back up there.
He's got his RMS hat on.
All right. So, handhold enclosure is 314.30. That's a handhold enclosure. But you're saying it doesn't have to be the size. It can be a lot larger. Here's the rules. Underground raceways and cables entering a handhold enclosure are not required to be mechanically connected to the handhold enclosure. Ryan, do I have anything in 300.10 where it says metal raceways and cables must be, 300.12 where it says metal raceways and cables must be mechanically continuous?
Well, that's the general rule. Yeah.
Yeah. Is there anything that says except for
you have
switchboards?
Yeah, exactly. Exception to raceways and cables into the bottom of open-bottomed equipment, such as switchboards, MCCs, transformers, things of that nature.
This is an open bottom equipment?
Yeah, typically.
Maybe not. Maybe
Yeah,
not.
if not, then make it open-bottomed.
Okay, you cut the bottom out. Okay, good.
But you do need your bell end.
Well, again here,
If
it
it's
has
4
to
gauge
do
larger.
with, do we need to provide any kind of protection on the PVC, and that's a function of whether or not it's 4 gauge and larger. And then how you provide that protection. Handhold enclosed covers must have identifying mark and logo to identify it as an electric handhold enclosure. Pretty straightforward, you buy them. Handhold enclosure covers must require the use of a tool to open, or they must weigh over 50 pounds. So you need a tool to open it, or it has to be over 50 pounds. Well, one way to solve the problem is that where you need a tool, put a wire around that and leave the wire there. And then, of course, then it saves you from having to go out and find the tool because it's already there. Metal covers and exposed conductive surfaces of handhold enclosures containing branch circuits or feeder conductors must be connected to an equipment grounding conductor based on the rating of the overcurrent device. So if you have a metal cover and handhold, we have to connect that cover to an equipment grounding conductor. We talked about this clearly in grounding and bonding course and how important it is because people have gotten killed by metal covers becoming energized on handhold enclosures because it was not at one time required by the code. Here's an example of a ribbon. And Victor, this is what you're talking about. You're saying, there's a handhold enclosure. It's a little larger than what I've been demonstrating before. But in this case, it's showing that you have the bonding ribbon on there, that the cover is connected to an equipment grounding conductor. All right, well, this is the end of the first DVD of 2 DVDs relating to wiring methods and material covering Articles 300, let's see if I got it, 310, 312, and 314. I want to turn to my team. I want to thank these guys. I think they've done a fantastic job. Also, those of you who watch the DVD don't realize, but we're video live streaming all this material. And we have a lot of people from around the country giving us information, asking us questions, providing information that allows us to do even a better job. And before I close up, I just want to take a look at Wilson and ask Wilson if there's anything he has to say. Apparently not. He's very happy the way it went. And so we're going to be going on the next DVD, and Wilson will be following us. God bless, and have a great day.